That's it. Landscape. No, we're broadcasting in horizontal. Where you're watching from, because there's only, if you want horizontal, then it's on Twitch and YouTube. Everywhere else is literally one stream vertical. Morning. Now pretty normal start time for me. 5:30, 6-ish at the minute anyway. I've done a tiny bit of work on this yesterday, only 10-15 minutes at the end of the day. I think I put the crystal on, which wasn't on, and I think I tested this and added this, like just a couple of components really. I'm just going to jump back up to the top here as well, just because it's bugging me, because I want the board complete as I work my way down. So I'm going to put the switch and the DC jack on. I know there's stuff underneath here, but it's all stuff that we're going to be barely hot airing, so it's not going to affect the switches. I just want to see it complete. Yeah, YouTube, I can send you the link to the horizontal live stream. It's up now, like obviously on this one and on yesterday's. So let me just double check in case it's somehow not streaming, but I've literally watched it back. Yeah, it's up live now, horizontal and portrait. The one with portrait in the title will obviously say portrait, and the one with horizontal isn't. And I'll send you the link. Oh, that's this link. Yesterday's is there. So, where's chat? That is yesterday's link to live in horizontal. And today's, if you want today's link, if you can't find it, it is this one. So if you're struggling to find it, it's there, but no, nothing's changed and everything streams the same as it's always done. So it might have just been a bug on your end, maybe it's opening the wrong stream, is all I can think. And also the viewers at the top right of the screen is literally the horizontal YouTube viewers, because the vertical is a lot more. So we know the horizontal is running because we see the actual viewer count live of the horizontal one specifically. So if you have any other issues, just let us know, obviously. But doesn't seem to be any. I think it was probably just an issue on your end, I think, on that one. That's the DC jack on. And then now we want the power switch on as well. Same again with these. I kind of hold them in the air, keep my finger on them to keep them in place, and then solder one pad so we can then let go and solder the rest. So I tend to just blob solder on one like that, and now you can let go. Check your positioning's good. So that all looks fine. Check it's flat to the board, which it is. And now we can solder them pads. I'm going to adjust this overhead light as well, I think. Give it a bit of a tilt because it just seems to be the perfect position for glare, with it being a top-down light right above my head. So I'll probably change that to just get it tilted slightly, because I'm always having to tilt the boards as I'm working on them because the light's just quite glary. Retro 6 is actually because my software company is called Angel 6. So it's not just a random number in that sense. I've got other companies, and when I was deciding to make a retro company, obviously thought I'd keep it familiar. So just change the Angel to retro. Yeah, nice and clean. And I'll work through this a bit faster than the last one. The last one took me 2 hours to put about 7 chips on. I think we're a bit slower because I was kind of explaining processes. But now we know what we're doing. We'll crack through this and try and get it somewhat complete. We are fixing a PC Engine GT. So it's it's over here. So a customer sent in a PC Engine GT, all in bits, that doesn't work. And we're transferring everything over to my new circuit board. So we've got all the components on the back to do yet, and we've got some left on the front, and we're identifying them at the same time. So basically, as we're going, we're putting these through an LCR meter and identifying what components are what, so that we can get them pre-assembled in the future. So far, all the way down here I've done now. So if we go along this line here, we've done all of these. This is meant to not be assembled. We've done these, and I think I was just on, last night I was just about to put this inductor on. I'd got it off, hanging off the board here for testing, and let's see if I remembered to actually write that in the bill of materials sheet. No, I didn't. So that's pretty much where I finished off. So if I move that over to the screen, go down and chuck over the screen, you can see I got to L105, and then I must have forgot to write it down. I think it was right when I was about to have dinner. So let's just measure that one now. It's in position, ready to measure. And we'll have to help it out to tell it it is an inductor. Today is the same as yesterday. We are fixing a PC Engine GT. Yes, this was a 1.5 microhenry inductor. I had to test that in a few modes. So basically this customer's PC Engine came all in bits and not working. And we're just transferring all the components over from his old board to this new board. And while we're doing that, we're identifying all the components and filling out this Excel spreadsheet so we can identify every single inductor and resistor, cap, transistor, everything we can, with the goal of then being able to have these whiteboards pre-populated with most of the components, so that when we come to do this transplant in future, it's a lot quicker. And obviously you can buy these boards as well, so it'll be much quicker for customers to simply buy the boards off as mostly assembled. Instead of having to put, I'd say, a couple of hundred components on it, I guess. Tiny bit too much solder on. This one we're trying to make a really nice looking finish, just because I can. I don't normally. Trying to make it so it looks almost factory on the joints. There we go. I keep forgetting to get this. We've got a headphone jack, but I didn't pick one up again, so I'll probably grab one of those later. But other than the headphone jack, we are now up to this line here, really going across. We've got everything top side done, so we're now at the bottom side. We'll do this cap next, CC701, and I believe I already have that in my capacitor list. Let me bring that back up, because it's part of the cap kit we saw. CC703 is 100 microfarad again, so let me put that on. Always at work. Seems to be I think I'm slowly realizing I probably work more than some people. I love working on a Saturday morning though, before anybody wakes up. Nothing more boring than sitting in bed and wasting a Saturday morning. So this one's 100 microfarad, 6 volt, and hundreds are over here. And these ones flow really nice with the hot air, or at least the last ones I did flew really nice. So let's see if we can get this a nice clean connection. So plenty of solder on these, because these footprints aren't technically designed for the SMD pads, but they do work really well for them. Being that bit further away causes them to get a nice fillet on the cap legs. Yeah, that's exactly. I want to do this. I enjoy it, so that's why. You also have to find enjoyment sometimes in things you don't want to do. So you can make anything more enjoyable. It's mindset, really, isn't it? It's like I tend to clean the cars on the weekend now as well, just so I'm actually doing a bit more activity-wise. I've done it for a while now with the cars, but again, I never used to really enjoy that, so I found a way to enjoy it, basically, just changing your mindset so you actually enjoy doing it. Yeah, so look how nice them little fillets are now. That's almost like a perfect fillet that they recommend you make on all of your soldering, which I never usually get it that neat on general work, but that's such a nice connection there. It's exactly what they should look like. It's like a textbook finish, if you will. That's orientation that way. So we'll now do we'll do this again, because that's another part of the cap kit, C506. Or is that not part of the cap kit? Actually, I don't think I thought that was. Yeah, it's got to be. Oh, it's not C506, that's why. It's CC503. That's not in my cap kit. So that is a 22 microfarad, 35 volt. CC 503. We'll get to 22. Yeah, the clean comp HDMI. There is something out already. I can't think what it's called. There is like one where it's converts to HDMI, but it's similar to the NES and things like that. You'd have to override the TIA and read the raw video data and reconstruct RGB. And then after RGB, you'd have to reconstruct the HDMI. So it's all doable, but just something I've not really, haven't had time to do yet. There's a lot of people wanting the HDMI mods from me, and I will get onto them, but obviously I'm a one-man band in terms of the hardware design side. There's only me that makes the hardware, so while I'm busy doing other things, I don't get much time on the hardware. But yeah, it's something that people have requested. I just haven't had time to actually do yet. VR 500, that will be a potentiometer. And again, if you remember, we just have to measure these bottom two pins to figure out what size it is. So let's crack out the multimeter. Yeah, and you guys say I get up early and work, but all you guys are watching early. So how does that work? Are you guys not off? You're just mooching around and just monging out to the stream. We are fixing a PC Engine GT. So we are fixing this console here that's broken. We're first transplanting everything over to this new circuit board I've made. And we're measuring all the components as we go. So this is the room resistance mode, VR 500. So 16K. Again, there's not a 16K wheel. There's a, well, there will be, but not as standard. That could be 10K or 20K. So let's maybe put a bit of flux on the wheel. Reflow them pins to make sure we've got good connection. And then also IPA the wheel, because the wheel could be dirty and grimy. So let's really give this a clean. Let's try get an accurate reading. It would probably be turned as well. If it was the right size, it would. It doesn't want to turn. I think their little potentiometer wheel is seized up. It's not been used, so it's yeah, that's seized, that little wheel. Right, let's measure it anyway with the clean pads, see what we're getting. So we're getting exactly 16. Let me see. Someone on Discord sent me a list yesterday as well that they've also measured these components. Why does that link never work for Discord? They've measured all these components themselves as well. And done them with a similar LCR meter to me. So I'm just wondering if they've happened to measure that VR. So let me just check their message, see if the VR is in the list. It's not. So they've measured the caps, the inductors, and the resistors. There's a bit more that Discord isn't showing me. Yeah, unfortunately, they haven't measured that either. So I don't know what to think about that one. It's measuring 16K, but the thing is, it's seized up, so it's not turning. Let's see if I can crack this with another screwdriver. And obviously, the turning shouldn't affect the overall outer. There we go. So that's freed up. So let me just try and spray. I know you obviously can get potentiometers of all resistances for the most part, but you'd think it'd be fairly standard, and actually, is it written on anyway? Wonder if the pots normally have the writing. I've never really paid that much attention to the pots to see if the writing indicates the size like the resistors would. Measure that once more. See, now it's gone up to 24k. So now, just from cleaning and turning, and that shouldn't have changed, so this is obviously partially broken. Yeah, this is a PC Engine GT we're working on. So fixing a customer's PC Engine GT. We're just identifying every component first. So you can see this studio glare. Now we've cleaned and turned it, we're getting 24k. Now this shouldn't have really changed that value, because obviously turning the wheel shouldn't change the outer resistance, but it has. But if I can do this. Oh, and also we're doing the thing I said not to do, actually. That's probably the problem. I'm measuring it while it's in circuit to get out of. Let's take this out of circuit. Yeah, someone just picked up literally what I was doing. That's going to be the issue, because it shouldn't change resistance when you're turning the wheel, and it's moved it up to 24. So obviously, take it off. I'll probably tack one leg on there just so it's in place, and now we have it off the board, but still attached, so I can now probe better. For this computer thing, I think I saw that comment yesterday. We don't really work on anything but the retro stuff now. We're just too busy, unfortunately. Right, so that's 55k while it is warm. So I really don't know what to make of this one. It's all over the show, the reading wise. We had 16k, then 24k, now 50k, which could just be the actual pot on its way out. So it could be a 50k, and at the minute that's our best guess. I'd probably want to, not attached to the board, that one. I'd probably want to test this on another. Where am I looking? Where's it gone? Let's come off here. Yeah, I probably want to look on another PC Engine GT to like double check that reading, unless anybody else has got one or ever done the reading on that, to double check basically what we're thinking. But this seems to be reading. Yeah, it's very stiff, that is, as well, so it's definitely worn out. Give it one more IPA, turn it a few times just to kind of work that IPA inside, and then if we're still reading 50, then I'm going to class that as the reading for now. I'll put a question mark there, just because I'm not 100% satisfied with that. It's not been consistent throughout the readings. So there. So it seems to be fairly settled on that 54 reading now. So could be right. Probably is right. And whacking that camera. And the 50k is a standard value. So let's presume it's 50k. And that's for, I think that's for the negative 20 volts contrast circuit adjustment, to adjust that 20 volts. So the higher, typically the higher, the lower the voltage it'll be. So the higher end wouldn't matter too much anyway. So I'm going to put a 50k on a brand new one, and we'll make a note of that as well. So I've got a 50k over here. We don't need it on his board. Clean up this desk. And then we'll put it on VR500. We also need to make the note in the bill of materials. So VR500 is a 50k question mark. And we'll leave that one at that, because until I come on to another PC Engine GT, that's going to have to be the presumption of what that value is. It's like I say, very likely correct, but I'd like a double double check. And again, with these potentiometers, what you want to do is, because they should survive just going straight over, but I like to get a bit of flux on it first so it doesn't blow all the way off. Warm up the pads on the board before you put the pot back down, so you can see the bottom ones have melted, the top one has. Drop this in, let it find position, and then if you nudge, you can see it pulls into position. So it just means the component's under less heat as you're working. They are designed to survive the heat, but why put it under the heat until you need to? So just a little tip on that one. This flux definitely cleans up way better than all the others as well. The more I'm working with this, this is so far my new favorite now. This Styri HT-TF, that's definitely my favorite one to work on. So we'll do R503. That should be an easy one. In fact, what I'll also do, let's get rid of these caps. Now I've done the caps on my board over here. These are just distracting to make you think there's still something on the board up here. And these are the really terrible Chang'e caps that are just globally known as fake value capacitors. So if you ever see these Chang'e, get them off and bin them. They're as good as not being on the board. They were basically, what you'll get is you'll buy, say, a 100 microfarad cap, and it'll be like a 10 microfarad. They just save money on faking the values and sell. They obviously got popular at some point, that's why they're everywhere. And then I presume somebody found out they were fake, and people now know it, but they must have got away with it for a long while. So they managed to get popular at some point for like cheap capacitors, but yeah, avoid them like the plague. This fuse we've done, I'm just going to cut him out of the way. So he's not on this board, we've already replaced him. I partially super glued my cutters yesterday, or the day before, so now they're all stiff. That's on the customer's board. We've also removed everything up to this point, all the way across. This was the burn that the customer originally did. I think this is where they got up to and then decided they were not going to be capable of doing it, so they sent it in. So they kind of burnt a bit down here, burnt a bit up here, and then sent it us before it got more damaged, which is a smart move. You better, not continuing if you think you're going to cause more damage. Right, so there's 503. We are dealing with a 473. So that says 473. So as we know now, 47 and then 3 zeros, which will be 47K. I'll just measure that on the multimeter as always, just to be sure, even though we know for sure the values written on resistors. I still just like to double check, because if we're putting them back on the board, it might be a faulty resistor, and then we've transferred a faulty component over to the new board. So even though we know the value of the resistor, we still need to measure it. So we will prepare this footprint, and we don't want too much solder on the resistors. We find out if you're going for this really clean finish, they bubble up a bit too much. I don't normally care about it, but like I say, we're trying to aim for a really almost factory looking finish on this one. So that one isn't giving me the nicest visual. Slightly slanty and a little bit too much solder, so I'm going to come in at it with the iron again. I just want to try and get this line nicely. There we go. Iron did the trick in that instance. And did we forget to put that on? We did. 503. I need to try and remember these because I keep transferring them over and then forgetting to add them to the sheet. 47K. I'm looking at the stream to see these. I mean, I can see them with my eye anyway, but I'm actually looking at this overhead stream that you're seeing to solder. I just get used to, obviously I usually use a microscope. I've used a microscope all the way through. You get a depth of perception. But since doing the streams, I've had to get used to really not using the microscope because otherwise you guys can't see as well. So this stream has got a very slight delay, like very slight. Luckily, anything more and I wouldn't be able to do because as you move your hand, the delay adds dexterity issues. You're kind of looking at your hand moving and then correcting for it too late. But luckily, I'm literally soldering off the live stream feed using that as my microscope, and I've just got used to it. It's taken some getting used to because it's not as good as a microscope. But now I've become really good at looking up at the screen and soldering down on the board. We have now, do we go across here? That's the not populated, that's in. The wheel I have, I'm definitely not going to put him in until last though because he's super easy to melt. We already melted this one. I've got a replacement coming for this now though, luckily. However, this one you cannot find replacements for because I've taken that one off and, well, we took it off on stream, but I've figured out just by basically measuring it while we were off stream, this is the common pin. These outer two are, you can think of it as like two potentiometers, like two of these little potentiometers. You've got one where there's the outer ring, I'll use this. So this would be like one outer ring, this is the other outer ring, and say this, I think, is the middle one. So this, this, and this are like having these three pins. It's a single ring. And then obviously, because this is a dual, you've got this one, and this one are then your second ring inside, which is completely normal. This is just a dual pot. But what isn't normal is you see this thick trace, that's the giveaway that the two circles join together here. Well, everyone that's ever sold now, these changed this standard, and this was not standard. So the join is normally here, and so the two rings are backwards on this one, and you cannot buy this way around. So if you look on AliExpress for dual potentiometer dials, as they call them, you'll see this thick line. You'll just about see it on the images they show. If it's upside down, the thick line's actually over here. And if you see through from the top, on all the ones they sell, the thick line's over here. So basically this is backwards. So we don't want to put that on to last because if we melt that, we've got no option at the minute. So we'll leave that off. We'll probably do, let's just tackle this area then. Let's stay in this area now and focus on here. We are building a PC Engine GT for a customer. So I'm transferring all the components over. Just give you a quick look at it. So this is the customer's PC Engine GT that's faulty, and that's this original green board here. This is the white board I've made, and we're transferring all the components over so that we can hopefully get this working and measuring the values as we go so that we know what they are. So we'll do R502 next, which is, if we look at it here, 272, so that should be 2.7K, which is a standard-ish value resistor. And obviously, measuring it in board, if I get a different reading, I'll take it out, but yeah, that measures 2.7. So that is a kind of a double check. The value says it on the resistor, and it measures the same even in circuit. So there's no point removing it to triple check because we've got already two checks that are valid, and it'd be very hard to get a valid reading if it was going to change in circuit with another resistor and happen to be the exact same value written on the resistor. So that's enough confirmation for me that we have the right value. And then after that, we've got C506 next to it. So don't let me forget, if you see me swapping these components over and you don't see me stopping for typing on the keyboard, just remind me I've forgotten to write the value in the BOM, because I keep doing that. I keep measuring the value and then not making notes in the BOM, which is one of the main reasons for doing this. At least it's all recorded though, so if I forget, I can always go back and find it in the stream, although that'll take a long while. It's probably quicker opening up the PC Engine than it is finding me talking about a value in the middle of a stream. Right, C506. So for that, we want to wire up it. So it's fun. Plus, the more work I get done now, the more time I can have off at another point in time. Saturdays are way too long to not do something either. I can't do nothing all a full day. I'd go stir crazy. I tried it, not recently. About probably a week or two ago, I tried to do nothing on a Saturday, and it made it 10 times worse. I was absolutely sick to death by about 11 in the morning. I can't sit there and do nothing. I can do that for a few hours at some point in the day, but otherwise I've got to keep myself busy. I could play games. I could jump on Resident Evil and play a ton of Resident Evil, but I want to do this at the minute when my mind's all active and full of energy. This is what I want to do. Put a bit of IPA on this, cool it down a bit, save waiting. Yeah, I think there's also a sense of reward when you've done work as well, so you feel like you've actually achieved something. Right, it's measuring 25 nanofarads at 1 kilohertz. So if it is small, we're going to crank up the frequency to 100 kilohertz, which is where I'd normally test small capacitors, and we're still getting 25 nanofarads. So I'm going to say that's correct. I've also got this sheet that somebody else on stream sent me, and they've used a similar LCR meter. So let's see if theirs matches my measurement as well. This is C506. So it's good that we've also now got a double check. C506, they measured 30 nanofarad, you see. I'm measuring 25. So let's try in the 10 kilohertz range. And I think they said they were using an Atlas. This Peak Tech is a lot more accurate than an Atlas. This is probably the most expensive and accurate LCR meter you can find. So that's going up, and normally what we could do is get another 25 nanofarad if I had one. I've got some high quality caps. Because what you'll find as well is when you're measuring caps of a certain rating, they won't ever measure the exact same value as what you buy. They just, obviously they work on frequency and temperature and things. So if we find something roughly in the nanofarad range, all these are picofarads. Because every cap I've got spare going to be picofarad caps. 22 micro, gone the other way. I want to see what, ideally, like a known working. Right, okay, there's 3.3 nanofarad. It's the closest thing I can find. We'll see. I know this is quite a way off 30, but let me see what 3.3 measures. So if you bear in mind, based on percentage, not value, if this was a 30 nanofarad cap and it's measuring 26, we'd expect a 3.3 nanofarad to measure 2.8 or something like that. In terms of percentage-wise, that's probably what we'd expect to see if it is going to be a 30. No, so yeah, it's 3. So yeah, not far off. It's underrated slightly at the 10 kilohertz. So let's find the frequency that it likes to measure at. So they're measuring the same. So it's 100 hertz, the slow. We are getting 3.1. So not much variation, but there is a drop. So that means this one would probably be measuring slightly. Ah, there you go. Slower speed, it measures 29. So that's at 100 hertz, which I wouldn't normally measure small capacitors at low hertz, because it just means that if they're used for high frequency filtering, you're not actually getting 30 nanofarads. Because obviously, you bear in mind, the whole point of this will be to filter high frequency, typically. So yes, you're thinking you're getting 30 nanofarads, but then as soon as the frequency approaches, say, even 10 kilohertz, which is not fast at all, it's pretty slow, the value of the capacitor, the value of the capacitor has now decided to stay. I wonder if that's just because it's cooled down now. Let's try it back at the 100. Yeah, so I was just testing too soon, impatient. Needed to let the capacitor cool a bit more to bring up the capacitance. So that is 30, and that's the use of having a double check somebody else that's done the measurements. Otherwise, I would have wrote probably 25 nanofarad down there. So that was useful. C506, 30 nanofarad. And next time we will let the caps cool a bit longer, especially small ones, really. We need to let cool a bit longer. Up early, it's like the top comment of the day. So let's put him over now. Yeah, it's the Doom chair's definitely good. I think I've mentioned it on stream before. I actually brought this when I didn't have the money to buy it. I shouldn't have really brought it, but I'd seen it in an offer. I think it was on Overclockers, who are actually, they're mega popular now. Overclockers, they think they've gone global, and they're actually a Stoke-based company. I've known them since they had a small unit right by where I used to live in Newcastle. But I'd seen it on an offer, and I didn't want to buy it because I'd already got a Noble chair. And it just kept popping up, like emails, like, oh, and I keep seeing the Doom chair. So I ended up spending like, I don't know, 400, 500 pounds on it when I didn't have that kind of money lying around. And I really shouldn't have brought it, I just wanted it. But it turned out to be the right decision because it is a good chair. It's definitely worth the bling factor. It's another one. We're still in Stoke. We're in Milton now, but we don't have any stores anymore, like walk-in stores. Off to work shortly. Working on a Saturday, just like us. I think it's. Do you get any time off in the week if you're working Saturdays, or is it just 6-7 day a weeker? Yeah, the kids love Stoke City. I'm not a football fan at all. I've never really taken to it. Never really watched any sports, really. Don't watch that much TV. Did we write that one down? C506, yes, we did. Right, so let's do this Q506. So this will have to go in the component tester. We're fixing a PC Engine GT. I'll show you in a second. Next time we zoom out, I'll show you what we're working on. But it's a handheld gaming device, basically, similar to the Game Gear. Yeah, nice. Get some downtime. Then you can play some retro consoles. So let's now get this component tester out. We'll go on each 3 pins, and the default we're doing at the minute on these is we're saying any component we look at. I forgot to order another thing for the iron as well. I keep saying this every time. I might get a new iron just for the sake of changing it. Like still using the JBC tips, but a newer model, because this thing's wanting to die. So any chip on here, we go left to right. So when you're looking at it, how you typically look at a chip, which is this way. These tweezers are doing it, and they're dead sticky. We'll go pin 1 on the left. So 1, 2, 3. When we solder the wires on, that's like the convention we're using, and we're sticking to it. If you want to clean tools as well, this is the best way. Really heat the tweezers up. then get a bamboo cloth. That's what I'll do. Spray it with IPA and rub it while it's hot, basically. That's the key. Because this thing just keeps sticking together on me. Alright, so now we should not have to keep dealing with sticky tweezers. Right, pin 1. I think a lot of soldering as well, it's more about just technique, and I can teach anyone to solder super tiny components. I could watch you do it and tell you what you need to change or tweak. A lot of it is just literally technique. Basically, you don't need super accurate vision or hands or equipment or soldering iron tips. Like you can see, the size of this tip's as big as the component, but we can solder onto it. What I normally do when this moves, we did on the last one, if it moves again, that's fine. If it moved again, I'd tack one of the legs onto the circuit board to hold it in place while I tacked the other 2 wires on. That's the second one. Third one is here. So if you see these packages as well, it's not always, but I know this is a transistor, so it's 3-pin. The tab at the back and the middle are always the same pin. It's like I say, there is components very rarely where that's not true, but it's certainly true for these transistors. That's the 3 pins on. Oh yeah, the 2600. I've got one of them built up. We built one up by mistake. I don't know what made us think it was a Lynx we sold, and we thought we sold a 2600. So we refurbished and fully modded up a 2600 with the clean comp, and then realised we built the wrong console. So that's sitting there until we sell another. Alright, so now component tester tells us this is a PNP transistor this time. So if we look at the component tester, we have a PNP transistor, and what we need to write down, we don't care about the current. So this IC is the current through the base, current through the collector, between the base and collector. And that is not important because we're going to overrate these things. So all we care about is the designator, which is Q506, that it's a PNP, BJT, which they all are on this board. There's no FETs on this board, or no MOSFETs rather, but I'll put in BJT into the spreadsheet just so it's blatantly obvious, but they all are going to be. So we have pin 1 is base, so I'm going to do 1 equals base, 2 equals collector, 3 equals emitter, VBE, which is the important thing, but again, these are all pretty standard. The voltage before it goes into saturation. Nothing else matters, so double check got that right. 1, 2 is collector, 3 is emitter. Yep. Yeah, thanks for joining in. I'll catch you in a bit. So that's that one done, and you can see how much quicker it is now to test the components. Now we've got this little setup pre-configured with the wires already. The first component we were testing took about 10 minutes to obviously find the component tester, get the wires stripped, tinned, soldered on, explain to you guys what it's doing, whereas now it's a little bit faster and we can work through this a bit quicker. I've also ordered, for this connector here, I've ordered some new ribbon because the one that comes with the cartridge connector is completely melted. It's not suitable for taking off, really. So we're going to replace that with a ribbon. And I'm also going to solder in a connector here, so it's literally you can unplug it. So this one on now. Oh, we're already on there. Just need to zoom in. Ah, yeah, we got a lot of work on. Got to keep up with it. Thanks for the sub. I think we're trying to build a. I don't think the Twitch is ever going to grow because we're not really known. Only like, how'd you get started on Twitch? I've streamed for about 2 or 3 weeks on all the platforms. Every other platform's grown, and Twitch is like one person. It's just I've got no idea what you do to get more people on there. Not that it matters, but it's just it's interesting that every other platform's got a lot of people. I've noticed as well, people that use Facebook, you're not up very early. So any early morning streams, I've noticed almost nobody on Facebook. Whereas it's like the other way around. Late in the day, we get tons of people on Facebook and not as many on the other platforms. So it's funny how you can kind of see the trends in different platforms as well. Whereas TikTok's always crazy. Like TikTok's always the most busy for me. Any time of day. Part of a computer, yes and no. It's a PC Engine GT, a little handheld retro console. So looks similar to I'd say it looks like a Game Boy, but the colour and styling of a Game Gear. Plays PC Engine games, and we're basically transferring the customer's components off his green board that's broken onto a nice brand new white board that I've made. Alright, so we'll do resistor 513, resistor 530. Oh, there, I was going to say that's not a resistor, that's a cap. It's there. 1030, so that's going to be a 10k resistor. Let's double check that. Yep, 10k. Let's get them swapped over. No, nothing needs programming. There's no chips on this board. This is just a one-for-one replication, if you will, of the green board. So it's just all physical components that are being swapped over. Right, don't let me forget to write that down. 10k, 513. I wonder how many of these I'm going to forget at the end when I come back and look at the sheet that should have everyone on. How many components that are going to be missing. Ah, nice, you're studying. What are you studying there? Like electronics or just computer science or something? We have CC700. That's a known cap from my cap list, and that is I can find it. CC700, 100 microfarad, 6 volt. CC700. Computer systems engineering. Nice. So it's a bit all round then. Bit of learning about everything, I presume. Like the whole, not just the specifics, but the entire way that things are made up. So the only downside to this flux that I say is really good is it is that making the tweezers sticky pretty fast. Not a massive problem because as soon as I warm up the components for this to go on, the tweezers unstick because they get warm. Right, so I broke that one. Next, let's do the other big one while we're here, CC504. CC504 is another 100 microfarad 6 volt. So CC504, that's in the spreadsheet. Let's do the same on here. It'll be interesting to see whether this actually works as well when we finish, because obviously the customer had a non-working, like he doesn't know if it works, basically, the board, and there was many issues. There was no video, no audio, so I'd say it's going to work. My gut feeling is this will work fine when we finish with the transfer. Usually all the capacitors rotting just cause trace damage, and your main issue is just trace damage on the board, really. And now we have a little C510, which is here. Let's remember this time to let him cool down before we measure, and not just blob him with IPA, trying to speed things up. Sack him onto the side so we can probe him easy. Give him a minute to cool down, and then we'll measure him. Nicely. Yeah, I used to do that. Used to have a business in that, so you probably can't find anything about it now. But if you looked up the Xbox 360 Arbiter rapid fire controller, I used to run an entire business employing 16 people, selling hundreds of modded controllers, like genuinely hundreds a month. We were building about, I think, 20, 30 a week on average when it wasn't peak. That scene's like died a death now. There's not really a scene for it, but let me see if I've got any old stuff in that business. I might do. Show you a little picture or something. Modify, yep, Arbiter 3. Let's have a look. Yeah, so I've got all my old artwork I made as well. Like, we had little manuals for it and everything. So we had pull this up. Like this, the Arbiter rapid fire, and we used to have like the ultra fire, rapid fire and auto aim, ultra fire drop shot with LT cancellation. All these things weren't even a thing at the time. I'd like to think I kind of made these up. The quick scoping, so you tap LT, it's a quick scope, and then triple shot. Turn it all on and off. Dual button remapping, everything. I did all these. Come with a little CD. So I had the manual that came with, like, in a CD case, the mod chip came in. So this was the CD case, front and back. So that was the front of like a CD case holder. And then we'd slide the flexible PCB inside. See what else we've got. I didn't really have many photos left of the actual stuff. That was a little mascot we made, a little robot. These are just all, this was a manual, come with a full printed manual of how to use the modes, because it was quite, oh yeah, we did PS3 as well as Xbox. Logo art, this is all downloading, that's why it's taking time. I think I made these as well. I used to use, yeah, I did, it was like Photoshop back in the day. Just literally drew it all up, but it looks quite good looking back on it. But yeah, that's getting a bit distracted there, but yeah, that's it's funny how you're working on that, and that's something I've actually ran an entire business on as well. Oh, that cap's hanging off down there as well. Right, let's measure this one. Bring the LCR meter in. And this is measuring 150 nanofarad on the dot. So I'm pretty confident that one's going to be right, because that's a very standard size. We'll double check with that sheet we have off the other person on Discord that shared it with us, and it's for C5. I've covered it to C510. They have got on theirs 120. You see, they've got on theirs, and we've got 150, so it's going to be 150 because it wouldn't read higher. The capacitors almost never read higher; they read lower. So I'm going to put 150 on mine for C510. Did we say? Yeah, C510, 150 nanofarad. And you're not too concerned about stuff at that level anyway, isn't that crucial? So 120 nanofarad versus 150 won't make a difference in a circuit, not a circuit doing what this is doing. So it also doesn't matter too much how accurate that one is, but I'd say it's definitely the 150. C204. What I'm going to do as well, as I'm doing them, I'm going to write them down in here so I don't forget. So I'm going to, in the spreadsheet, I'm going to write down these components that are around here. So I'm going to write down C204, R204, D208, anything in this area. So if we end up moving out of this area and we realise we haven't filled them in when I look back at the sheet, it'll give me a hint to go back. It's probably a better idea. And we've done the others. So we've got 1, 2, 3, 4, 5, 6, 7 components in that area. 1, 2, 3, 4, 5, 6, 7. Right, that's all the components in this area. So now if I work away in this area and forget at some point, it should be pretty obvious that I've missed checking a component. That's probably not a bad idea. All right, C204 we'll check next. And I think using the iron to move it over will introduce a lot less heat than using the hot air and waiting for it to cool down. So what did I say that was? C204. The other person got, they wrote down C204, C203 twice, but I presume it will be the second one down. So they got 45 picofarad. Doesn't seem, I think 47 picofarad's a standard size. I don't think 45 is that typical. Let's see what I get. I get 53. So it's more than likely going to be a 55 picofarad. I think it's fairly standard because this is slightly underrated. So I'm going to say that's a 55 picofarad. 55 picofarad. That is for C204. Yes, it is. Let's transfer him over. And we'll probably do the capacitors in this area. So I can keep the LCR meter turned on and then do all them first, and then I can turn the LCR meter off while we test the others. So these two are the other capacitors here, and we've got one more here. So they're all tinned up. Bit of flux. And hot air them off the old board. There's that one. Thanks for the follow again. Been some nice followers this time. I wanted to have as well, like show the number of followers and likes and things, but I think the stream's going to get a bit cluttered if we add too many things to it. I've managed to fit quite a bit in this stream without it being too cluttered with overlays. But it would be nice to see, like, if nothing else, the number of likes or things on like TikTok. There's tons. We get thousands of likes on TikTok. And it'd be nice to kind of see a bar going up as we're going. At the minute, we have the Rusty bed fund instead. So if you went to streamlabs.com/retro6, that's where you pay for Rusty's new bed. And we've got a £10 donation in there towards that one so far. It's better than advertising. See, 202 and 203, I reckon, are probably going to be the same. The other guys got 55 picofarad for both of them, so I bet these three are all the same. If we move this off to the side. Might as well do this one at the same time. There we can now test these. Oops, that is a little bit overdry. Good morning, Patrick. Welcome in. Well, it's morning for us anyway. Might be night. It's probably night time for most watchers. Let's see what these measure. I reckon they're going to be 55 ohm. 55 picofarad. Or they'll measure probably 53. No, you can't see the meter, can you? Bring that in. Still can't see because the glare. There we go. Let's see. If they measure 53, then it's likely going to be the same. So this measures higher. So this is measuring 64. Let's see what the other one measures. And considering it was measuring 45 on the other, so this is 10 picofarad above. Let's see what some standard capacitor sizes are in picofarad, because it's more than likely standard sizes, you see. So standard capacitor is in nanofarad. See, the 60s isn't common in a sense. It goes from 47 to 100, but the next closest one is like 68 or 75 if you go off like resistor values and cap values. So I'm going to say that's likely a 67 picofarad cap for them too. So 67 picofarad for both. And again, as I mentioned, it won't make a huge difference if we're slightly out on them values. Yeah, Saturday 8 AM. That's, where's my clock gone? 7 for me. So an hour, 1 hour earlier. Let's measure this last cap, which is already hanging off the board anyway on the customer. C511. This looks like obviously a bigger, so it's probably going to be like a 10 microfarad or something. C511, we have that it should be 985 nanofarad, so it's just going to be a 1 microfarad. This is, I'd say. Let's test. No, it is actually coming up as, yeah, there you go. So 1,000 nano is 1 microfarad, basically. So it's a very, very common standard 1 microfarad cap. That'll just be usually a little bit of bulk capacitance on something, which could still be filtering at that level. So we'll chuck it on to, I don't know why I've got me iron screaming at me all the time. Chuck it onto here. And we can do the other two now. We've measured them as well, so all three can move over. This one's got too much solder on the end. Yeah. twist that around. Get these off green board. Thanks for the follow again. It's nice to be able to see that now on the TikTok, having the actual follows pop up, because you have no idea. I have to look back at the stream at the end and see how well it did and if people liked it and stuff, and now I can kind of see a lot more happening as we're going. Ooh, burnt my finger there. There we go. So now we have a flip of the little sniffing devices. Probably could, yeah. Friday, 11 PM for somebody. That's got to be, what, West Coast maybe? I know East Coast is like 6 hours behind. So yeah, I'd say either mid or West Coast maybe. The green board is the customer's original. So this is a customer's that basically got the console sent in, and this green board is dead anyway. There's loads of rotten traces, burns, pull pads. So they've paid for a board swap anyway into this new white board we've designed. But we're just measuring all the components as we go, just making it. It would only have to do this once, and then once we've got this sheet, then we don't have to do this again. So it just takes us a lot longer the first time. Well, it's not the first time we've done the board swaps, but this is the first time I decided to stop and get all these components figured out once and for all, so we can add them to our assembly. We can then get all these components pre-assembled at factory on the boards, and there's a lot less work to do then. Hey, morning from Sussex. What's the weather like? Still black. I can't even see outside yet. Right, so this one will probably actually, we don't need. Yeah, what I'll do is I'll leave that tagged on there a minute, so I can attach 2 wires. And I'll do the same for this one. Ooh, hot. Make sure I don't mix these two up because they're 2 different ones, so they're still left and right. Come on, steady there we go. Now we can bring in the little component tester. We can solder on the wires. So we'll have pin 1 is the black one. In Cali, nice. I bet it's not miserable, wet and cold there yet. It's freezing over here now. It's like, well, I'll say freezing. It's not really freezing for most places, but for us it is. It's like still 7-8 degrees, I'd say, on and off. Red is next. Oh no, we can't do red next because it's attaching the board. We'll do green next. That, and now we can do the red last. So we'll take that one off. And we'll zoom in because I can't really see what I'm doing there now without a little bit of zoom in on the camera. There we go. Cloudy, yeah, it's going to be another probably cold and boring day then. It seems to have gone from really sunny to overnight just cold, didn't it? We had really good summer this time for the UK, and it was just like out the blue. It was just cold one day and then never came back. There we go. So we've got a double check first that the black wire on pin 1, and obviously it goes in here as 1, 2, and 3. So black is 1, red is 2, green is 3. So that's all correct. Now let's see what this reads. Oh, interesting. Doesn't only stick around there. Unknown port. So that is a bad transistor. Oh, actually, it says D on the board. Yeah, so this is going to be a diode package, because if we look on the board where it's going to go, it actually says D208. So this is going to get confused somehow. So let's lift one of the pins out and test just, say, pins 2 and 3. And it'll probably figure out then it's a diode. There you go. So it is a diode with pin 3 as the anode, pin 2 as the cathode. So let's do dual diode. Pin 1 equals, we don't know yet, pin 2 equals cathode, pin 3 equals anode. And now if we say there'll be a common pin between these two. So let's just say, I think last time in this package, we did the outer 2 on them, so pin 1 and 3. And if we see a volts drop of 1.4, we know we've spanned over 2 diodes. If it's still 0.7, we've got it right. That is not a capacitor, so that's got a bit of capacitance. That's probably what's confusing the tester, that it's got a bit of capacitance between pins. So let's try pin 1 and 2 now. There we go. So this is pin 1 is now a anode. So actually we'll put A, anode 1. Actually, we don't need to do that because it doesn't make any sense, because it can only be one thing. 2 has now got the cathode, which is both cathodes, so it's a dual cathode one. So, like the other one, what I'll do is draw this out. No, it's a diode. It's a dual diode package, this is. Only for the fact that it says it's a D. So we know it's going to be diode. The Q there is going to be a transistor. But what this one is going to be is we have a little package here, leg there, leg there, leg there. Obviously, super elongated. We have pin 1 is an anode, so this is pin 1. So we're going to have a diode like this. So the cathode then is going to pin 2. And then this one, pin 3 is an anode. So basically, we've just got a package like this with two diodes. So there's 2 diodes with a shared cathode, is all that one is. So pretty simple. I just realised that might look like something else to some people. That's 2 diodes together, nothing else. Right, let's transfer him over. Did we solder them pads? No, we didn't. So we'll get this one put on before I lose it. And yeah, I've made the note and it's the right one. Pins on that. Tiny bit of flux, or way too much flux rather. Oh, still got the component attached to the tester. Oh, I didn't write down the voltage drop. It's bog standard 0.7 volt. I'll just write that down in a second. The flux, it basically prevents the solder from drying out. It stops oxygen. Well, it does more than just that, but stops oxygen mixing in, keeps everything flowing, and allows the solder to obviously form nice blobs. Without it, you would get dry joints. So if I solder, say on the customer's board, I don't want to ruin my nice solder. What we'll do is we'll put, say, solder on this pad first, and you solder. See, now that looks fine and clean and shiny because the flux, the solder itself has got flux in. So at the very inside of this wire, there's a tiny bit of flux. So you don't need flux when you're first soldering, but if I don't reapply the solder now, and I just keep using this, you'll see it'll start, as the smoke dies off, see that tail whip now when I'm pulling away, that's now dry. So see how it's like dragging the solder away with the iron? That's how you know it's kind of dry. It's just not forming the nice balls when you pull away because the solder's getting dry. So that's what it's doing. It's hard to demonstrate because I think as well, when you've got a good technique, it's quite hard to get things to not work right. But you can see that's now not flowing the best. It's like pulling away and leaving like a tail. So if I apply flux to, well, just apply flux to that one, no extra solder still, and go back in, you'll see what happens to that now. It forms a nice ball again. So it's gone into a nice perfect sphere. And you can do it quite a bit now because there's flux around. So that's not going to dry out now. And all that smoke is the flux burning off. And this brown is the flux burning. But you can see, importantly, the solder joint is staying nice and circular constantly. Like, look how long we can go with this flux. And eventually the flux will burn off. And then we'll start getting whips again like that. So, I mean, well, no, it's still going, but you'll get the idea. That will dry up like this one would, and then end up making the dry joints, if you will. So it's to make sure the solder flows correctly. What's next? The other one we need to test now. So we need to attach pins to this one. So we'll do the same on this. We'll attach the legs of the component tester. We better put this back in before we forget the third pin. And now the first one is the black wire. Ham radio license? No. One of the neighbours where I used to live in Abbey Alton used to have ham radios, and I had a surround sound system I wired into the bedroom. And I used to pick up all the radio interference at night because I basically had a big antenna in my ceiling, the loop of the surround zone. So I'd be sitting there in the middle of the night and I get woken up by random callers. Plus, then we had a church opposite, and that had a similar thing. I don't know what they were doing, broadcasting the church audio, but couldn't get any more spooky. But in the middle of the night, you just hear that hum, hum, and it was all the church, basically, like whatever they were doing in the middle of the night. It was like what they were either playing or doing was coming through my surround sound. So I basically created a giant antenna in my bedroom to shut me up every night. But if you didn't know what it was freaky as, like we'd just been woken up to, like, you know, you think you're like in a horror film where you're about to get abducted or the exorcist is coming or something. But I realised after a while it was the surround sound speakers picking up all the signals. We are making we're not making, we're transferring all the components off a PC Engine GT handheld games console. So at the minute we're measuring all the components and finding out what they are. But it's basically this little handheld gaming doofer here. And this is the customer's green board. This is our whiteboard. And we're transferring all the components over one at a time, but at the same time, we're then testing them in component testers and things to find out what they are. So then I can get them pre-assembled from factory with most of the components on. That's the goal. So this one is hopefully going to test okay. Oh, that's not good. There's a wire come loose. No, all the wires are on. Let's just reattach these. Not having much luck with these last two. So that is bad. So we can double check my work. I know it's not going to be super clean, but it's going to be attached wire, so we know that's the important thing. Those wires are definitely attached. They're soldered on. Pretty solid as well, to be honest. Go from the other side. So you can see they are definitely soldered onto that chip. Unfortunately, that is a dead component. So we're going to have, let me just reattach or re-grip the wires to the end. See if it picks up then. No, so we are, I think, based on that, the fact it thinks it's a resistor, pretty much dealing with a dead transistor there, unfortunately. So we'll have to put, well, there's no point in putting that on the board because it's not right. We'll leave that as dead in our spreadsheet, which is Q507. And then we can come back and I'll get my PC Engine GT, or if anybody else, maybe that viewer who's already tested a lot of components on his board as well, could maybe, I wonder if he's actually done that. No, he hasn't done the component testing. So either I can do it or somebody else will do it at some point. We'll have to come back and test that component, but that is dead. So in one way, that's also good because that would be why the screen isn't working. Actually, we don't even need this. Luckily, we don't need this component for the customer's board because Q507 is bypassed because this is part of the backlight contrast circuit, I believe. So luckily, we don't need that. That's to pass the voltage through to the LCD, and we're replacing the LCD. So it won't affect, hopefully, the customer's ability to have a working console still. But we do need to measure that at some point so we can get the full reading. I think I've missed a cap as well. It's a C5. Yeah, I have. I didn't write that one down. That was 1 microfarad, wasn't it? So it's a good job I wrote these notes. And I've missed a resistor as well. So R204, I didn't write down, or have we not done that yet? We've not done R204. Cool. Hey, welcome from South Africa. So actually my favourite accent of all time. I love the South African accent. These are going to be 4 of the same resistor. Need a bit of hot air on there to clean that off because that's all the flux sticking to the components. There we go. And that is 104, I'd say they are. So that's going to be 10 and then 4 zeros. They should be 100K. So let's measure them. We're in resistance mode. Go over one of them. And there you go, 100K. So that's 4 lots of 100K. And I think it's an 0402 package, but I've designed the PCB, so I don't need to make notes of the packages. I've got the actual Gerber files. How you can learn, you can watch what we do and pick up little bits of what we're doing. I'm all self-taught, so I can't really give you any specific advice on, you know, a lot of people ask what sort of tutorials or videos or books or things kind of read and stuff or learn from. I've never read any, so or even if I have, I've glanced over like the art of electronics only recently, and it's a load of stuff that is really cool, but it's not how I learn, and it's very textbooky for me. I'm a hands-on kind of figure it out myself, and that's how I learn. But in terms of learning stuff like this, I think you can't just beat hands-on, just practical experience, basically. So we will pre-tin these pads. Flux. Hot air these off. The component tester is just a cheap one. I probably want to buy a slightly better one. I've never seen much of a need because I rarely use a component tester. So it's just literally whatever cheap one you find online. But the LCR meter, which is the important one to test inductors, caps, and resistors accurately, that is a 1 second. looking at me tester and not what I'm doing. Let me just get this resistor pack down first. There we go. The LCR meter is a Peak Tech 2170. I think it's about £600, something like that, when I brought it. Right, so that one's dead. So what I'll probably imagine, we're going to be cleaning the board and it's disappearing. I just got to try and remember that's missing, basically, from this board. We have now a C709 on here, and that should be 10 nanofarad, apparently. So we shall see. Just joined what we're making. We have a PC Engine GT for a customer. We're repairing this. It's having a screen upgrade when we're finally done, an LCD screen upgrade. But at the minute, the green board's knackered, which is the customer's, and we're moving it over into the white board that I've designed. So we're slowly transferring all the components over one at a time and measuring them as we go. That's that. Where's the... Am I blind? Where's the cap there? Couldn't see it for a minute then. I was looking all over the board. Gets a bit more confusing, find out where you are when there's no components left on the board. So we'll move him out of the way. And then we'll test him. So we're looking for 10 nanofarad, I think I said. This one should be. And again, this will just be the... actually, it won't be the smoothing cap at 10 nanofarad. Be a filter cap. Yeah, 10 nanofarad. The iron is set to 390. I need to make a note of that cap as well before I forget. So it's 10 nanofarad. Hey, thanks for the follow. So that's a C709. So yeah, I should definitely make the notes that I've been doing, like pick this area now and write down all the idents, because that definitely helps me not forget, because I did already forget one. So D206, D204, R201, R200, CC505, D205, CC704. Right there, what we're dealing with. Inhaling, yeah, I've got a fume extractor. I normally run it if I'm doing a lot of soldering and I'm not on stream. I'll run it. When I'm on stream, I should run it. I do sometimes, but I find a lot of the time I'm not doing that much solder. And when, I know it doesn't sound the best, but when the smoke's going up, I try to move my head and not inhale at the same time, if you know what I mean. But no, it's something I should. I said if I could find like an actual extractor that worked better, I would. But when I go between soldering and hot airing, the hot air blows the fumes anyway, so this fume extractor doesn't work. So I'd be turning the fume extractor on just to solder for 2 seconds, then turning it back off to hot air, then turning it back on. It's like not convenient. I could probably do with a soldering iron where it has the fume extractor built in, but then it gets in your way. So when you're using an iron and you've got the big extractor tip floating around, I don't know. Maybe something overhead, like a main overhead extractor. I'm more than willing to invest in one. It's just finding the convenience factor between working and constantly having a extractor turned on and off all the time, basically. But yeah, it's I don't think it's good for your health. I don't think it's like really, really bad for your health, but it obviously isn't good. I don't think I get that much fume inhalation that I'll have major problems. But like you see there, the smoke's rising up in front of me, and I don't breathe in when that's going up, and then it goes above my head, and we have an air purifier behind as well to help. So we've got some kind of filtration in a way. Oh yes, we don't need that one. CC505 is a 100 microfarad bulk. And then we have CC505, 100 microfarad, 6 volts again. CC704 is 10 microfarad, 16 volt. So we'll get the 10. Benefit to the board, it's a one-to-one clone, this board is. So other than looking cool and being brand new with no torn traces, this is literally a one-to-one. I basically got a full working PC Engine like this, sanded it all down, scanned it all in. So if you want to see them original scans, you can go to retro6.wiki. Let's see if I can pull something up and show you this. Go to the wiki, overlay the screen a minute. Where I'm from, Stoke-on-Trent in the UK. PC Engine GT, if we go in here, the website glitches sometimes and refreshes back to the top. Go to board scans, and then this is the fully working PC Engine that I had to destroy to sand down, get through all the layers, scan all the circuit, and then I redrew every single part of the trace, had it made as a circuit board, and then I've also made a little bit of software that we have to wait for boot up because it's a free service. Don't bother paying to host it because I pay enough in hosting the wiki and everything else. So if you wait for this to load, you'll be able to interactively zoom in and out of this, put markers on and follow traces nice and easy. So just another thing that helps people if they've got torn traces on their board. So this loads in. This is now the board scan you've just seen, but you can zoom in now, nice and close. Say we wanted to follow where that Q507 went, you can tap down on the mouse, pass through the board, go to the other side, and get right back to the top. So you can basically go through the board like an X-ray. And this is the best view in between the two. So if you look at this view, you can see there's the bottom layer or top layer, whichever you want to call it. And this is the other layer. So you can kind of see the overlays. And what you could do is say, oh, there's the transistor. I want to see where this via goes. Double click. Go to the other side of the board, and you've got a clear marker where you were. Follow this trace up. Go all the way up. You can see it runs up right along the edge of the PCB. Gets to here. Goes through right the way up. And gets to here and stops. But say it passed through another via like this one. You can do the same thing. Double tap. Go back through the board the other side, and then see where it comes out. Follow it along. You know, that's the whole point of it, basically, being able to follow where every trace goes. So that's all free and available on retro6.wiki in the PC Engine GT section. This is all about fixing a customer's PC Engine GT, and we're just transferring all the components off his green board onto this white board and measuring them as we go, so we know what the values are of all the components. clean this up. CC704. I think that's where we're at. Did I write down? Yep, 10 microfarad. We've got the cap out somewhere. No idea where I put the cap. Yeah, not the cap out. Where are we? There, so CC704. Resistor packs we might as well chuck on there nice and easy and quick. And they are. And I know one thing we didn't do actually, we didn't measure the last resistor pack to make sure it wasn't faulty. I only measured one of the pins. I should have measured them all, because as we're putting this over, we need to make sure the components actually are fully functional as well. So let's just measure every pack. Yep, that's 100k, 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 and I already measured that one, so that's fine. And then on these now, we have, zoom in nice and close on this. They are 562, so it's going to be 5600, so 5.6k we're expecting on all of these pins. And I do know these typically fail. This is a semi-common point of failure. When I've repaired these in the past, you normally find one of these as bad. And I think they go to something to do with the data pins. I think these are, or either way, they're pretty critical pins for the system working, if I remember rightly. So if any one of these is bad, you won't get any boot. Yep, these are all measuring 5.6k so far. Yeah, all them are good. So we can swap them over. This is getting quite sticky. I better clean this up in a minute. The flux that's flowing underneath. Pre-tin these legs. It's like my soldering iron wants me to buy a new one. Stop beeping at me. There we go. That hasn't got a bit of. How are you meant to know which one's which when they haven't got a number? Which one are we on about? Like what component, in a sense? These resistors going on, they're all the same. They're all in a row, so as long as you put them on the same orientation as well, then it'll obviously be correct. And we know which ones the components are because we're taking them off the exact same spot on the original circuit board and moving them over. So we know, we know what goes where because we're basically measuring it as we take it off and making sure we put it back in the right spot. Yeah, they all say 256. They're just resistors. So, like this is just one resistor here. These are just 4 resistors in a row. They all just basically you could almost cut a line down the middle of them and treat them as 4 individual resistors. They're all the exact same value. They're all 5.6k. So they literally don't need to be in any particular order or anything. So let's make a note of that. 200 and 201 are 5.6k times 4. Now we have 3 diodes, I believe. So we have, and if we know the diodes, I don't know why we're wasting the time putting these in a tester. Like the diodes, we just need the multimeter and diode mode. Literally all we need. So the multimeter and diode mode, we probably have to take them off the board if we don't get a consistent reading, but let's also look. We have an N and an underscore, and an N and an underscore. So the chances are it's going to be exactly the same as this component. If we look at this one, we said on 208 that it was a dual diode. Pin 1 was an anode, which is the red. So pin 1 is anode. Pin 2 was the combined cathode. So we should be able to touch on here. And yeah, we've got 500 ohm breakdown on the diode and 500 ohm breakdown. Oh, I'm in resistance mode. So we should be getting a beep. Menu, go to the right mode would help. Right, now we're in diode mode. So lock on here, and you hear that beep. That's the multimeter telling me it's a diode. It's got a breakdown of 0.56 volts. And the same on that. So if I show you what we're doing, because we know it's a diode, we don't need the component tester, so that'll save a lot of time. There's the multimeter. If you touch pads, it's going to beep because it's dead short. And this is diode mode. But if you go over the diode on the board in the right way, so this is where a diode is, it beeps to tell you there's a diode and it tells you the volts drop. If you go the wrong way around, you shouldn't get a beep. Nothing should happen at all. So that's basically how you test for diodes. So knowing that, we can quite quickly test these other ones. We don't need the component tester. It's a lot slower to do that. I'm not sure why I didn't even think of that. This should almost definitely be the same one then, because it's got the same writing on. So this should be the cathode. This should be the anode, which it is. Same voltage breakdown. So D206 is identical to D208. And then this other one has, I think it's got the same marking as well. Just a bit dirty. So let's try the exact same on this one. Yep. Yep. So those 3 are all identical. So that's nice and quick. We don't have to mess with component tester and wires for them. D205 we didn't do. Let's just hedge your bets and say this is exactly the same as well. And it is. So there we go. 3 or 4 diodes all in the same spot, all the exact same component. So they're all the same one. Linux phone, I could do. I've made the world's smallest Linux computer at some point a few years ago and showed it off at CE. I always say CX because we've got a store next to a CES in Vegas. I've demoed it there years ago, but it's not something I'd be doing now. No interest in it really. We'll get some flux on this side as well to clean the pins before they move over because they're quite grimy. So I'm just going to flow the flux on here and leave it to bubble up a little bit first. Yeah, we've already created the entire circuit board. We've just basically, in this instance, we've just remade this exact PCB identical because it's just to help people with rotted circuit boards with trace damage. So we haven't designed anything as such here. This isn't like hardware I've made like the other components. This is just a remade PCB, like an identical remake so that you can recover damaged PC Engine GTs from basically the capacitors leaking is what kills these. I'll make a note of that. I'll just copy and paste it onto the spreadsheet. What I'll probably do as well, mind you, it doesn't matter. I was going to say I can say that it's the same as the other number, but they've got the same text, so I'll figure that out. 1, 2, 3. It's all then made a note of. So what we're looking like, this is missing because it's a dead component on the customer's board. All this is done. That connector's not on yet, but we have got quite a bit of hot air in, so I don't want to put that one on. All that's done. All that's done. That's a no fit on the board. It doesn't actually get soldered on. That I just keep forgetting to grab. I need to grab one so we can put that on. The wheel I'm putting on last because it melts. I've got a new one of them coming because I melted it myself. So we've actually only got, it looks like, these components on the front, and we're done there. Unfortunately, we have this load of crap on the back here I've got to work through after, but I don't think that'll be too bad. I'll blitz through most of them because they're just simple components. But let's aim to get these done now, these last few here. And then we feel like we've got somewhere. We've got some kind of a goal. We've got R714, so let's do the same again. This is working well. I'll pull up the sheet, and what I do is pick an area, and then I'll start writing down all of the component designators in that area first, so that when I start measuring them, if I forget, I've got quite easily a sheet that looks like I've missed something. R710. They are going to be all resistor packs. That's R709 and R708. So I think it's just 1, 2, 3, 4, 5 resistor packs and a single resistor. And then we've got this cap here that you can't really forget. You can, but we'll put a through-hole cap on there, CC702. So let's probably do that one first. And that's actually a 470 microfarad cap, so a large cap. So we need to use an aluminium for that anyway. So that's a CC702, 470 microfarad. Oh, 470 microfarad, 6.3 volts. So let's put CC702 on first. And for that, 470. Do I have one under here somewhere? I think these are all way larger than 470. So I'll just get the normal kit, which is right at the bottom. Of course it is. And we'll get 470. Oh, look at that. My kit is missing the 470. The only one I needed. Oh, we've got a 470 10 volts. That's fine. I was lucky. Let's put this in. Make sure we get the order right. Long leg is positive, goes through there. And then what we do with this is zoom out a bit so you can actually see something. Pull focus. Put the, see the positive on the board there. That positive there means that the long leg of the cap, see how one's longer, that's the positive. And the stripe is indicating, in this case, the negative. So we'll push it up, lift it up in the air a little bit, and bend it down, so that we can get it in a nice position. And we probably won't solder this in at the minute because, well, actually we will, but we'll just bend it up out the way after because the resistor pack is right under this cap. So we'll do that, solder him in place, and then we can just lift him up out the way while we solder that and push it back down. Or why not just, yeah, he's in now. Let's just solder him in. I was going to say why not just wait until the other one's in, but let's just solder this in. There we go. Yeah, it's not that hard, to be honest, with practice. It's obviously hard enough. It's definitely a skilled thing, but nothing's as hard as it looks once you take it step by step. Right, so that cap's in. We'll lift him out the way, and then we can always plonk him back down when we're done. So now for the, I think I made that board dirtier than, it wasn't that dirty, and I wiped it, and then it looked dirtier. R714 we'll start with, this one here. And that is right around here, which says 101, so that'll be 100 ohm, I'm guessing. Multimeter in resistance mode. Yep, 100 ohms. So I'll tell you what, we will make notes of what they all are and then do all the transferring over. Save stop starting and writing one down and then going back and forward. We'll measure everything first. So 714 is 100R. 712 is, what does that say? 101, does that say? Yep, 101. So they're going to be, these are the ones I'm on about. They're on the data lines. I think these are reflection resistors that stop reflection of high voltage, high speed voltage. These stop the line rippling. So they're all going to be 100. These are the ones that are normally bad. When I mentioned, I thought it was these ones down here. It's not these that go bad. It's these that normally go bad. And these cause the system to not boot at all. So 100 ohm, 100. Yeah, all good. Yeah, apparently the T900 transformer, I have looked. A viewer mentioned yesterday, I think it was, that you can use the Game Gear ones. I didn't think you could. I don't know why. I've never really looked at it. And then when I've looked at the layout and dimensions and pinout and everything, it does look correct. So I haven't physically installed one myself, but I have placed a Game Gear transformer in there and it does look correct. It does look like it's going to work. So I'd say fairly confidently, yes, you can, and you're not really gonna harm anything trying because it's a high voltage circuit. So it's not gonna be that susceptible to certain voltages. It's a fluorescent tube, so it's just gonna consume the voltage either way. If you freewheel it with no load, it gets up to 3,000 volts anyway, and then when it's loaded down, it gets to 200 or 300. So you've got quite a bit of playroom there that I don't think you're gonna have an issue just trying it out. That is 100R as well. And this is 10, so there's 3 lots of 100R times 4. 709, however, looks like it says 820, so that'll be 82. And I can't read what the other one says, so let's test this one. Yes, that's 82 ohm. Yep. This one I can't really read the writing. I think it's don't know. The middle just looks like 2 circles. 1, 2 circles and a D. That looks like to me. Let's see what it is. Could be 180. Oh, sorry, 18. Yeah, 18 ohm. So it's 180, as in 18 and then no zeros. And that's quite dirty. I need to clean that because the multimeter won't probe through all that flux. There we go, 18 ohm. 18 ohm. 18 ohm. 18 ohm there, all good. Yeah, if you got the backlight, it's working then because the T900 is the backlight. The T500 is the contrast circuit, and funnily enough, the like on this customer's board, this Q507 is dead. So the contrast circuit goes from this T500 down here through this lot, through this diode. This VR500 is related to it. Comes along, goes through all this, and ultimately just generates a negative voltage. You can use a Game Boy original clean power. Just use the negative voltage on that and pass it in straight to the output pin, which I don't know off the top of my head where all that is. I just know you can do it. And then that bypasses the entire contrast circuit on here. So it's still recoverable, but I'd probably just chuck a modern screen in unless you're really fussed about it. 710 was 82R times 4, and the other one was 18R times 4. And that was, yeah, 708. So that's all them written in. So let's get these tinned up. And there we go. Now let's transfer over. Oh, we've got a bit of daylight starting to show. 8 o'clock and it's still pretty dark. Oh, that one's there. Just floating in midair. I don't know, I think I must have blown that off when we were warming up the other ones and not noticed. I think the resistor packs all benefit from a slight touch up with the iron. The iron had stopped complaining at me. This is definitely going in the bin. I'm going to buy a new one. C505. C50, just C505. Let's see if we've done it yet. Whereabouts is it on the board? And I'll take a look for you. Let me just clean this board up as well, because this desk is getting a little bit sticky now. How would you keep stuff from blowing away? It's just surface tension. So once the components would blow away if they weren't touching some of the solder. As soon as the solder adheres to any component, that's why I kind of hold it with the tweezers before letting go. As soon as it's melted into a bit of the solder's grabbing onto the component and stops it blowing away. So you have to kind of get the component to bond with a bit of solder to begin with. As soon as it's on any form of solder, it'll kind of stay in position then. Top near the power regulator MOSFET, which is on the other side, so we haven't come to it yet. C50, what did we say? 50. Where has that message gone already? Where the hell's it gone? C505, there we go. So it is 503. There, C505. So I can test it now. So we'll just go on the back for the minute. Tweezers are, I think, Mechanic KS something. I've ground through them. KS11 maybe. Set it out the way. Get the tester on. 303. It's measuring 365 nanofarad. I'm gonna say it's a 370. Whatever's the next closest standard to 370 nanofarad, and it'll be an 0402. It'll be 6.3 volt, but you might as well put higher in. The higher, the better. Standard capacitor values in nanofarad. 330 is the closest as a completely stock one, so it's not going to be 330, it's not going to be 470. Yeah, so it's measuring 360. What else is there? So there's nothing totally stock between 330 and 470. You wouldn't normally find one between there. You obviously can get, you can get a 390. So I'm going to say it's a 390 picofarad. Sorry, 390 nanofarad. That'll be. So, and that'll be more than good enough. Yeah, so 390 nanofarad, or if you haven't got them, 0.1 microfarad is like 100 nanofarad. So maybe 100 at work, but you basically want the 0.39. I would have said though, if you'd have put a 1 microfarad on, that's 1,000. This is 390. Oh no, it's a fairly critical feedback circuit for the voltage. If it's to do with this, which it might be, just swap it for an 7805. I wouldn't bother fixing that circuit with the transistor. Just swap it for an LDO, a 5 volt LDO. And I think there's a guide on retro6.wiki on how to do that in the power circuit section of this. Let's just move him back on so I don't drop him. Come back to him when we're actually on the back side. Right, where are we up to? Oh, I was just cleaning the board, wasn't I? Let's give this an extra little bit of a clean as well. And I think we're at Nice little milestone there, to be honest. We've got now the top of this board mostly done. This can bend back down, revealing that I haven't cleaned that pad. There we go. So we've really got all of that board on the top done for the most part. This I'll just grab and solder on when I get time. This component is bad on the customer's, but it's not needed for his. And the two wheels I'm not going to put on until last minute because I melted one and the other one I can't replace. So we want to keep them well out of the way of any heat until we're done. And then this connector over here. So other than basically the plastics, the ancillaries, if you will, this top side's all nice and done now. And I think looks, if you'd agree, quite clean. I think we've done quite a nice job there on soldering. You'd almost think it was factory assembled looking at that. And then I'll probably run it through the dishwasher when we're finally done, get it even cleaner. But it's pretty spotless as it is. There's not really anything on there. 390 nanofarad you want, but I'd say anywhere from 3. I think you might have to be fairly accurate, so I'd probably stick to the 390, but 330 might work as well. Yeah, it's all looking nice. I think that component's meant to be missing, and all the pins are looking good. So I think we'll call it a day at that. It's just a nice breaking point. I'll go get the cars cleaned before the sun's even up, I guess. And then I've got to tackle this. So I'll probably, that's not much there. And then you've got like this huge area. So I'll probably just work through some of this now offline. It's a long, I've done like 3 streams on it already, and that's all we've been doing. I might come on when I'm in the middle of it just so you guys can see it getting near the end, or I might wait until we've soldered everything on and then stream trying to bring this up and actually get it working and installing the screen, because there's obviously a lot of this work is just because I'm documenting all the components, so it would never normally take. I'd have probably swapped all these components over in an hour, maybe 2 hours. Probably 2 hours, I'd say. I'd have swapped all these components, whereas it takes like, I don't know how long this has taken, probably 10 hours. I bet we've been on this just to document every single chip on this side and try to find alternatives. Plus, obviously, talking in the stream slows you down a bit. But yeah, that's that one there. Hope everybody does something enjoyable for the weekend. I'm going to get the car washed, I think, and then maybe have a break, or maybe the other way around. And I'll just leave this desk all set up as it is, because I'm just going to be coming back onto it later, no doubt. I'll probably just keep coming in and chopping away at some of the bits, start working on this side of the board. Thanks everybody for joining, and I'll catch you again maybe later, maybe tomorrow or maybe Monday. I don't know when I'll do, but I'm sure you'll see me around.